Now we look at another example where it says that if you have a closed loop process and the open loop transfer function is given by 1 over negative s plus 1, it asks whether is the system stable under open loop condition. And then the second question asked is, can a proportionally controller stabilize the process? The third part is, if a proportionally controller can stabilize the process, what is the range of this case C for which it can be stabilized? Now we can look at the closed loop response, but before going to the closed loop response, let's look at the first question, that is the open loop system unstable. So we get for the open loop transfer function. Again, do remember that the open loop transfer function refer to the process. Okay, so when the loop is open, there is no controller, so we have only the process itself. So the characteristic equation, we write it this way, is negative s plus 1 equals 0. Again, the characteristic equation is nothing but the characteristic polynomial is nothing but the denominator polynomial of a transfer function, and when you set that to be 0, the corresponding equation becomes what is called this characteristic equation. The solution of the characteristic equation gives what is the pose. So we get s to be 1. So pole positive. So the system is unstable. Okay, so the open loop system is not stable. Now it said, can a proportionally controller stabilize the process? So for the second case, we see that this ys over rs, we can write, we'll have gp, again 1 over negative s plus 1, and gc is kc, it's a proportionally controller, and we'll have 1 plus 1 over negative s plus 1 times kc. Now if I simplify this, we'll end up getting kc over negative s plus 1 plus kc. Now see that for this case again, the characteristic equation we get for the closed loop system, that is negative s plus 1 plus kc equals 0, or we get s equals 1 plus kc. Now this is positive or negative. To determine that, so whether this is positive or negative, it will depend on the value of the kc. So see that if this is negative, then the process will be stable, and this is positive, the process will be unstable. So to be stable, 1 plus kc should be negative. Okay, so the answer to the second problem is that yes, it can be made stable. So to answer to the third part, we get that 1 plus kc should be less than 0, or kc should be less than negative 1. Okay. So a proportionally controller with a gain to be negative and the value less than negative 1 will be able to stabilize the process.